How are you, my friends? This is a continuation of the series Basic Math Terms, and this video is part 29, continuing some terms in statistics. Please, you can check part 28 also in statistics. Note number one, the algebra terms were parts 1 to 18, and pre-calculus terms were videos parts 19 to 27. Calculus 1 terms will start part 30 just after this video. Now the terms we will see here in part 29: variance, sigma squared, which is the variance, standard deviation, the sigma itself, the weather, climate, reliable, obesity, body mass index, BMI, and Greek alphabet, which we have seen in part 28 also. Just to remind you, this is from part 28, the mean. To find the mean, we find the sum of the terms divided by the number of terms. This is the same formula, guys, here. But if we are using a sample from the population, part of the population, we write here x dash or x bar, the summation of xi, I goes from 1 to n, divided all by n. The same formula, but we use mu for complete population, if you are using the whole people in this study. The variance is sigma squared. This is a Greek letter, sigma. Sigma squared, this is the symbol for the variance. It's a statistical term defined mathematically as the average of the square differences from the mean. So the variance measures how far a data set is spread out. The more spread the data, the larger the variance is in relation to the mean. How to find the variance? It's a little long process. Find the mean first. You have to find the mean. We have explained that in many examples in part 28. Subtract the mean from each value in the data set. So this is like xi minus x dash, or the same xi minus mu. If you are using a sample, if you are using a complete population. Okay, then you square each result from step 2. You square it, so you find x1 minus the mean, square it. x2 minus the mean, square it. x3 minus the mean, square it. Then you find the sum, we call it S here. Find the sum of the squares from step 3. You find all this summations. This is summation, xi minus the mean, all squared. I goes from 1 to n. Then divide S, this is the sum, the whole summation, by n minus 1. N minus 1, remember, for a sample, if you are using a sample, all this will be sigma squared. That's the variance. Or divide by n for complete population. If you are studying the complete population, divide by n. If you are taking only a sample, you divide the sum by n minus 1. Let's see. Example number 1 on a variance. This is the math quiz we have seen in part 28. We have the grades 11, 11, 19, 20, 16, 18, 11, 14, 19, 16, 8, and 5. See, these are the numbers: x1, x2, x3, x4, x5, x6, x7, x8, x9, x10, x11, and x12. So there are 12 students. Now I take xi minus mu. So 11, we have found the mean 14.83. We have found it. You just add all these numbers and divide by 12. You get 14.83. So 11 minus 14.83 squared, you square it. You get this result here, 14.67. Same thing here, 11 minus this number. So we have here the x, all these grades, minus the mean. See, 14.83, all this is the mean. You square it. So you get these green numbers here. Then you add it all together, 14.67 plus 14.67 plus 17.39 plus 1.34, etc., 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 until you get capital S, 165.62. Since you are using all the grades, you are not taking a sample, so the variance will be sigma squared, the summation here of all these squared, S 165.62 divided by N. N is the number here of all the people in this study, which is 12. So 165.62 divided by 12, you will get 13.8. This is the variance. Let's see another nice example about newborn babies, which we have seen also in part 28. We have 9 newborn babies. So this is X1, X2, X3, X4, etc. until X9, which is 45, 49, 50, 53, 56 until 47. We subtract the number here minus the mean. The mean we have found 52.3 also in part 28. This is X dash. Why X dash? That's the mean, the average, or the arithmetic mean, because we are using here a sample. So we put only X dash. So we subtract Xi minus X dash all squared. We get these green numbers here, 53.29, 10.89, etc. You add all these numbers here, the sum will be 192.01. Now we need the variance. The variance is sigma squared. The summation, which is the capital S, we divide by N minus 1. Why N minus 1? Because we are using a sample of the newborn babies, not all the newborn babies. So 192.01 divided by 8. 8 is coming from 9 minus 1. Remember, in the math quiz, we divide by N because we are using the whole population in the class. So 192.01 divided by 8, we get approximately 24. This is sigma squared, and this is the variance. Standard deviation is the most important. Standard deviation is a mathematical tool to measure how far the values are spread out from the mean. Standard deviation, we can abbreviate that by capital S, capital D, and most commonly we use sigma. See, SD, standard deviation here, look here, SD, standard deviation is the same as sigma, or this is Greek alphabet sigma. It is the square root of the variance. That's the bottom line here. So you have to find the variance first. Whatever that number, take the square root. So just simple example, if the variance is 25, take the square root, it will be 5. So the standard deviation will be 5. Standard deviation cannot be negative, so it will be always a positive number. Standard deviation close to 0 indicates that the data points tend to be close to the mean. A low standard deviation, if you get a low standard deviation, low number, means that more reliable data set. If you get a high standard deviation, less reliable data set. How to find standard deviation, I explained before. Just one step, take the square root of the variance, but you have to find the variance with many steps, as I explained before. Example 1 on standard deviation. Let's take the math quiz. We have 12 students here and 12 grades. We have found the mean, 14.83. We have found the variance also, sigma squared, 13.8. Now the standard deviation is the square root of the variance. So this is what we need, SD, capital S, capital D, standard deviation, or sigma, or this letter sigma, the square root of the variance, the square root of 13.8, which is approximately 3.71. So that's a little low. Another example on standard deviation for newborn babies. We have found the mean, x dash, which is 52.3. We have found the variance, which is approximately 24. Let's find the standard deviation, which is sigma, the square root of the variance. Square root of 24 will be approximately 4.89. Now, what is the difference between weather and climate? Weather refers to the short-term atmospheric conditions like daily, weekly, or even monthly. Climate is the weather of a specific region average over a long period of time. So when we say climate change, it refers to long-term changes in that weather. A nice example on the next slide, summing up parts 28 and 29 of statistics videos, including weather, standard deviation, passing through the mean, and the variance. Now, in this example, we see the weather's forecast for two cities, City X and City Y, for the last week in degrees Celsius. So on Monday for City X, it was 30 degrees, temperature little high. Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday for the two cities. Which city's forecast is more reliable? Reliable means dependable, responsible, effective, efficient, vigorous, and trustworthy. Now, to decide which city's forecast 7 days sample is more reliable, we need the standard deviation, and then we can compare for each one. So we start with the mean for city X. X dash is the mean. So we add all the temperatures here, 30, 29, 28, 32, 29, 30, and 27. You can check the numbers, divide by 7. So we'll get 29.3. This is the mean. Now the variance formula, we can use sigma squared. This is the variance, the summation of xi minus x dash. Here we have to find 30 minus 29.3. 29 minus 29.3. Then each one squared, you see? So these are the temperature for the 7 days. And this is the average or the mean, which is the same. You find the difference. Then you square it. It will be positive numbers. So these green numbers are the squared of the difference. Then you add all these numbers. You will get 15.43. You divide by n minus 1 because we are using a sample here. So 7 days minus 1 will be 6. 15.43 divided by 6 is 2.57. This is the variance. Now, when we need the standard deviation, the sigma, we take the square root of the variance. Square root of 2.57, it will give the standard deviation of the city X, which is 1.6. Now let's find the standard deviation for the city Y. We start the same with the mean, which is 27.71. And then we find the difference between each temperature and 27.71. You see here, you square it, you get all these green numbers, you find the sum. S will be 63.4. You divide by 6, which is 7 minus 1. So it will be 10.57. This is the variance. Now to find the standard deviation sigma, the square root of the variance, which is 10.57 under the square root, will be sigma 3.25. Before here, we have found the standard deviation of the city X is 1.6. So which forecast is more reliable? City X is more reliable because the standard deviation is 1.6 less than the standard deviation of city Y, which is 3.25. This is a practice question to check your knowledge about parts 28 and 29. Given the body mass index, BMI, of a sample of 10 obese adults, 18 years and older. 38 is the BMI, 43, 31, 34, 35, 46, 39, 40, 37, and 30. What do we need to find? The mean, median, mode, the range, the variance, and the standard deviation. You can try it yourself, please. But after I explain the word obesity and obese, also I will explain body mass index, BMI, and how to find it by the formula in the next slide. Obesity and BMI. The word obesity means there is too much fat inside the body. It is a medical problem that you have to see a doctor for that. Now, it's usually based on your body mass index, BMI. BMI compares your weight to your height. So you can use this formula, so simple. BMI is equal weight in kilogram. Like your weight, let's say 85 kilograms, you put here 85. Divided by height in meters squared. Suppose your height is 176 centimeters. You put here 1.76 and then you square it. You see, you square that number 1.76, you square it. Then you divide your weight, whatever your weight is, divided by height in meter squared. You can use the same formula for BMI if you get your weight in pounds, but you have to get the height in inches. So you multiply the weight in pounds times 703. This is the conversion factor, divided by height in inches squared. You will get the same BMI. Now look at this table here. If you get BMI 25 to 29.9, then you are overweight, not obese, just overweight. If you get BMI 30 to 34.9, this is class 1, low risk obesity. And so on. If you get 35 BMI to 39.9, this is class 2, moderate risk. If you get BMI more than 40, so this is class 3, high risk. You have to see somebody for help. Now, this is some statistics you can read. Worldwide obesity rate has tripled since 1975. And then you can check the other. Over 3 million people each year, they die from obesity. Now, let's go to the practice question. You can try it yourself, please. Check videos 28 and 29 for all these definitions. The mean, you will find many examples. The median, the mode, the range, the variance, and the standard deviation. Here, standard deviation is 5.03 for these 10 obese adults. And this is the Greek alphabet I have put already in part 28. You can see these Greek letters we can use in trigonometry, in quadratic formula, in statistics, alpha, beta, gamma, delta, epsilon, zeta, theta, lambda, sigma, omega, etc. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.